Today we're going to be looking at exponents and scientific notation. So we'll start out by talking about exponents. Exponents are simply a shorthand way to represent a number repeatedly multiplied by itself. So let's take a look at an example of what I mean by that. If we look at 3 to the 5th, 3 to the 5th simply represents 3 times 3 times 3 times 3 times 3. So in other words, we take the number 3 and multiply it by itself a total of 5 times. If we look at the notation that we use with exponents, the number 3 in this example is referred to as the base. And the number 5 in this example would be called the exponent. And we might also refer to it as the power. So that would be 3 to the 5th power. Let's take a look at how to calculate an exponent with a calculator. I'm going to show you two different calculators here. First of all, how you would do this on the Windows calculator that's built into the Windows operating system. I'll also show you how to do it on a TI-83 or TI-84. If you have any different calculator, I can show you how to do it when we talk about this in class. So here's how I would do it with a Windows calculator. I would first hit the number 3, and then I would hit this key that says x to the y. And then I would put in the power, in this case is 5, and then hit the equal sign, and that would calculate 3 to the 5th for me. If I were to do this on a TI-83 or TI-84, I would first hit the number 3 again, and then I would hit this key. And you'll see this is a common notation on calculators. So even if you don't have a TI-83 or TI-84, you might have a calculator that has that. So again, I would hit the 3, then that symbol, which is called a caret, and then the number that I'm raising it to, in other words, the power, and then I would hit the equal or the enter key, and the calculator would figure that out for me. The next thing we want to look at is how do I do mathematical operations when I have numbers with exponents. So the first one I want to look at is how do I multiply numbers with exponents? Well, we have a rule that if I'm multiplying two exponents that have the same base, all I need to do is add the exponents. And I want to show you why this is true. So let's look at this example. In the example, I want to take 3 to the 5th power and multiply by 3 to the 2nd power. So you'll notice that they have the same base. And if we think about what each of these represent, 3 to the 5th is just 3 times 3 times 3 times 3 times 3. And then I want to multiply that by 3 to the 2nd, which is just 3 times 3. Well, you'll notice that really all we're doing is multiplying 3 by itself 7 times. So that's the same thing as saying 3 to the 7th. So the shorthand way then to calculate that is to follow the rule that simply says if I have a number and I'm multiplying by another number and I have the same base, and that's important. So 3 to the 5th times 3 to the 2nd means I'm multiplying two exponents with the same base, that all I need to do is add the exponents. So 3, and then I just add 5 plus 2, which is equal to 7. And so 3 to the 7th is what 3 to the 5th times 3 to the 2nd is equal to. Now it's important to understand that this only applies if you have numbers of the same base. So for example, if I had 3 to the 4th and I wanted to multiply that by 4 to the 5th, in this case I couldn't add the exponents because the base isn't the same. So I'd have to calculate out what each of those is first and then multiply those. The rule for working with division is very similar to the rule for multiplication. And in this case it says to divide powers of the same base, subtract the exponents. So let's first of all see where this rule comes from. In my example I have 5 to the 6th divided by 5 to the 2nd. So first of all, they have the same base, so I'm good to go there. And if we think about what this problem is, it's saying take 5 to the 6th, so 5 times 5 times 5 times 5 times 5 times 5, so there are my 6 fives, and divide by 5 to the 2nd, which is 5 times 5. Well, you'll notice what that's the equivalent of. I can cancel out a 5 and a 5, and a 5 and a 5, and so what I end up with is 5 to the 4th power. Okay? So let's see that the rule works the same way. It says, if I have this problem, 5 to the 6th divided by 5 to the 2nd, what I want to do is subtract the exponents. So that's the same as 5 to the 6th minus 2, and 5 to the 6th minus 2 is just 5 to the 4th, so that we can see the rule works. I want to look at another example with you, and here all I've done is I'm really doing a similar problem to what I just did, but you'll notice that the exponent I'm dividing by is bigger, and so let's see what happens. If I follow the rule, it says take 5 to the 2nd, take that power of 2, and subtract the power of 6. And so what I get is 5 to the negative 4th. Okay? Well, let's see what does that mean when we have a negative exponent. So now I'm going to do it without the rule, the way that I figured out the last one. And that is I'm going to take what 5 to the 2 is, which is 5 times 5, and I'm going to divide by 5 to the 6th. So that's 5 times 5 times 5 times 5 times 5 times 5. So there are my 6 fives. And now I'm going to see what I can cancel out. So I can get rid of a 5 and a 5 and a 5 and a 5. And by the way, it's important to understand when we're canceling out here, what we end up with is 1. I get 1 over 5 to the 4th. And so now we see what 5 to the negative 4th means. It really means 1 over 5 to the 4th. And so that's an important thing to remember, that in general, if I have a number a to the minus b, that means the same thing as 1 over a to the b.